Okay, so good day, everyone. So before we jump into the session, I would like to give a short introduction about Vladimir. So Vlad's footprint in the software industry goes back to more than 20 years. Currently, Vlad is a product leader for Azure API Management at Microsoft. Being excited about the product, in today's session, he will show you how to use a single API management solution for all your APIs in multiple clouds and on-premises. A warm welcome to you, Vlad.
Thank you, Mohan. Can you hear me okay?
Yeah, we are able to hear you good, Vlad.
Perfect. Good morning, good afternoon, and good evening, everyone. Today, we're going to talk about distributed API management for a hybrid and multi-cloud world. So let me tell you what we're going to cover in today's presentation. So agenda is very simple. I'm going to start with a very quick, literally a couple of minutes refresh on API management, just to baseline everyone and have everyone on the same page. This is not an intro into API management presentation, so some familiarity with the concept will be definitely required. It is a session about distributed API management, so we're gonna talk a little bit about what it is and what are the pros and cons of that. We're gonna talk about the self-hosted gateway, new feature of API management that enables distributed API management. Then I'm going to show you how to use this self-hosted gateway, how to deploy it, and how to use it in a demo, and we'll see how far we'll get with that. And hopefully I will have time to cover some roadmap items and answer your questions at the end. So with that, let's move forward. So API management. API management is used by API providers to expose the APIs to developers. They use API management to abstract, secure, protect, revise, and version, manage lifecycle, monitor, measure, and publish the APIs. And then have developers consume those APIs, discover them, learn how to use them, and onboard to use them. API management mediates calls between backends and applications that consume those APIs. It consists of three components. First is a management plane, which essentially is an API that wraps a configuration store. That API is used by Azure Portal, by PowerShell, by ARM templates, recently released Visual Studio Code extension. The second component is developer portal. That's how developers discover APIs that are published. That's how they learn how to use them and onboard to use them. And third component is the gateway. And that component essentially is a data plane for the API management. It mediates all the calls coming from applications to backends, applies policies for protection, transformation, creates logs and metrics, and does other things. API management is a native Azure service. It's well integrated with the Azure ecosystem. It is integrated with Azure Monitor, Application Insights, virtual networking, Azure Active Directory, Application Gateway, and such. And of course, it works really well with all the PaaS offerings for compute, that customers use to build APIs. And of course, it also can use APIs on-prem through virtual networking. So with that, let's go and talk about API management as it was up until recently when we released Self-Hosted Gateway. And I call it unitary API management. This is the term I sort of came across. I was trying to find antonym for distributed, didn't find anything that sounded good. So with unitary we go, right? So it's a single API management uniform in one place. So API management, as you can see, deployed in the cloud. Usually our customers have APIs in several locations. They could be in Azure, they could be on-prem, they could be on-prem in several locations. Let's say in headquarters and on the shop floor. They can be in other clouds. So the question is, how do you manage them with API management? And with unitary API management, the approach is very simple. You have a single service, is deployed in Azure. And of course, for APIs that are deployed in Azure, it works really well. Calls for APIs on-prem and in other environments and other clouds have to go through API management, right? So you have to actually establish these connections between Azure and all these other environments. Usually you secure them with virtual networking. And then, of course, in those environments, you have also consumers of the same APIs. And for them, the situation is actually not very good because they, in this case, have to actually go back through the cloud based API management instance to call those APIs within the same environments they are located in. So it's clearly suboptimal situation. So with distributed API management, all changes, right? We can actually improve things. So first of all, we could, continue calling APIs in the cloud, in the Azure cloud, through cloud-hosted and managed API management instance. For the APIs in other environments, we actually can deploy our gateway component, represented by this little door, right? Those gateways now can sit within the environments where the APIs are deployed in. They communicate back to the instance of API management in the cloud that they are connected with for configuration purposes and to collect telemetry. And in that situation, essentially, the communication again can be secured with virtual networking for better protection. And then the calls can actually go directly to the environments where APIs are in, and not through Azure Cloud, which definitely is an improvement. And for the consumers of those APIs within the environments, they can now also call the APIs in those environments locally without looping through the cloud, right? So as you can see, the traffic pattern is a lot better, is a lot more optimal in this situation. For the going to on-prem APIs through cloud, you can also do something like this, right? Where you actually stagger gateways and the call goes from the device or an application to cloud API management to on-prem gateway. And that essentially allows customers to keep private connection and not open public endpoints from their private environments. So that's another point of flexibility here. So let's compare distributed API management to unitary API management. And we have a few axes here, so we just go one by one. So consolidated management and observability. In both cases, one single API management instance can manage all the APIs in different environments. From the infrastructure management perspective, in the unitary API management, it's a cloud-hosted, fully managed service, right? So Microsoft is responsible for all the infrastructure management. In the distributed case, these gateways have to be deployed and managed by the customer in their own environments. So it's a shared responsibility for infrastructure management between Microsoft and the customer. Similar for uptime responsibility, right? Follows infrastructure management. If we can't manage infrastructure, we can be fully responsible for uptime of that infrastructure. From the latest in perspective, obviously, as you can see in the unitary case, the calls have to always go through the cloud instance, which is not optimal, and so leads to elevated latency. In the case of distributed API management, calls go directly to where APIs are located. They take shortest path, and therefore the latency is minimal and optimal. From the security and privacy perspective, since the local traffic has to go through the cloud, it is challenging sometimes to implement security and privacy requirements, as well as be compliant. It's definitely offers distributed API management offers highest level of security and privacy because it allows you to isolate the traffic and manage the traffic very flexibly, exactly the way you need it. And then lastly, extra egress charges. If you, for instance, have APIs in other clouds, obviously you are subject to that in the unitary API management case and not in the distributed case. As you can see, as with everything in life, right? There's give and take. And you have to sort of evaluate those two approaches based on those concerns, and maybe others as well, and decide if it makes sense for you to go with the unitary or distributed for your specific case. Obviously, distributed API management gives you additional flexibility, but you take on some responsibility for managing infrastructure and securing uptime of your deployment. Of course, there are some, suboptimal parameters with the unitary API management. So you have to weigh those pros and cons. So self-hosted gateway is a feature that enables distributed API management. And it is generally available now and has been for about a month. So what is it? Self-hosted gateway essentially is a gateway, a data plane for API management that's functionally equivalent to the managed gateway we have in the cloud. It is packaged differently. It's packaged as a Linux-based Docker container image. It is available from the Microsoft Container Registry and can be found on Docker Hub. If you can just search for Azure API Management Self-Hosted Gateway, and you'll find it there. So it is managed and observed from Azure. So these are not standalone solutions. They require outgoing connectivity to Azure and only outgoing connectivity, and it's just port 1443. So it's fairly simple requirement to satisfy. It connects to Azure API Management instance in the cloud, so it always has to be sort of associated with an instance in the cloud to work. And then, of course, pulls down configuration, pushes up telemetry. It is resilient to intermittent connectivity loss, which we're going to discuss in a few slides. And it is extremely simple to deploy, and I'll hope I will be able to show you today how easy it is to actually configure and deploy and implement that infrastructure with Self-Hosted Gateway. It's just a single container. It is really easy to evaluate it with on your laptop using Docker Desktop or Minikube. I'll be using Minikube in today's demo. And Kubernetes sort of cluster is the best deployment environment for your production needs. Kubernetes makes this heavy lifting of ensuring availability, scaling, rolling upgrades, and things like that super easy. So connectivity to Azure. So we already said it's connected solution, right? It's not standalone thing. Without connection to Azure, Gateway cannot receive configuration updates or upload telemetry. It is designed to fail static. So essentially it continues to function as is if it loses connectivity to the cloud. And it is has a feature where you can actually have gateways backup current configuration to a persistent volume to improve resiliency. And here's what it does, right? So when configuration backup is off, what essentially happens is if connectivity lost to Azure, Self-Hosted Gateway continues to run using in-memory configuration. But if for some reason it is restarted, since connectivity to Azure is not available, it can't initialize, right? So essentially it won't work after it is restarted. With backup on, what it will do exactly the same, right? So if configuration lost, if connectivity is lost, it's running using in-memory configuration. So nothing changes there. But if it by any chance is restarted, you're doing rolling upgrades, or you for some reason accidentally restarted your pods, they will use saved configuration to initialize and will successfully restart and continue working. Of course, no updates will be received, but at least the data plane will work in your environment until connectivity can be reestablished. From the observability perspective, you guys know that Azure API Management already mentioned outputs all the metrics and logs into App Insights and Azure Monitor. Self-Hosted Gateway does exactly the same. It is integrated with App Insights and Azure Monitor. We have support for metrics. Log support is coming. But also we enabled a local collection and display of metrics, which again, if I have time during the demo, I'll show you today. So first of all, we generate log that goes to standard out, and you can basically see it with a simple, Docker Kubernetes command. It also outputs logs using a bunch of different protocols and formats, which can be consumed, through a vast ecosystem of compatible tools that are available out there, commercially and open source. And similarly with metrics, it supports basically statsd in a bunch of different formats there. And those again can be consumed and displayed using a fairly large number of various solutions that are available freely. So again, you can monitor in the cloud, on-prem, or both. So it's all very flexibly configurable, and you can choose whatever configuration you like. So now we're gonna go into demo. And here is what we're gonna do. So we're gonna start with creating a gateway resource, which essentially is a construct in Azure. It's a logical resource, which allows you to then go and deploy and connect your gateways and associate them with that resource. And in that case, they will share in configuration. They will share in APIs that they will serve, and they will share in custom host names that you configured for them, etc. Then we're gonna configure caching for and test caching for the self-hosted gateway. Then we're going to actually create a configuration where we're going to deploy a replica of the same backend we use in the cloud to on-prem, and have essentially cloud gateway serve the backend in the cloud, and a self-hosted gateway on-prem serve the resource on-prem. And then we'll show you how to collect and view metrics locally. So hopefully we will be able to do all of that in the remaining time. And then we'll circle back and talk about what's next and answer questions. Mohan, in the meantime, do we have any questions that urgently need to be answered right now?
No, Vlad, you can continue.
All right, sounds good. All right, so with that, let me switch to my browser here. So I have an instance of API management right here. It's called One, and it has a single API, HTTP bin. So let's go and explore that API here. So just to show you, it connects to a web app running on app service. And within this app, we are running actually a container, which is HTTP bin container. It's available on Docker Hub. It implements a bunch of interesting operations that allow you to sort of play with HTTP and REST and debug things. So let's go back to our API. So for this API, we have just 4 operations. Delay operation takes a value in seconds, and what it does essentially, it makes backend delay for that number requested for requested number of seconds before responding. So if I put 1 second here and do a send, it will wait 1 second approximately to respond. Get is just basically an operation that returns some information about the incoming request. Post does the same, except that it allows you to submit a body. We're not going to actually use this operation in this demo. And then the status, it allows you to actually respond with the status that you requested. So in this case, I want to see what 418 response look like. So that's an API, and that's what we're going to go with. So for gateway, to create gateway, you go to the gateways blade. And as you can see, I have none right now. So I'm going to create one. So right now I'm creating a gateway resource that will allow me to then deploy gateway instances in my environment, and then that will be the resource that I will be connecting them to. So we'll call it simply gateway. Location is Seattle. That's where I am. Oops. And here we're going to skip description, and we're going to worry about APIs at the moment. So let's add it. So resource is created. There are 0 nodes attached to it, which is true, right? We didn't really deploy anything yet. So I'm going to switch to 1 hour, right? These were from my test before. So you see there is nothing going on there as well. So we have a few blades here, keys. You have a pair of keys, those used to generate credentials that allow self-hosted gateways on-prem to authenticate to Azure API Management instance, and basically tell us which gateway resource to associate them with. You can configure custom hostname configuration for those gateways. And as I said, all the pods, all the gateway instances running in your environment associated with that resource will share in that information. Similar for APIs. And then we have a deployment, all important. And here we can see that we've got token, we've got configuration URL. That's the URL self-hosted gateways in your environment will connect to receive configuration. We'll provide you guides on, and artifacts on how to deploy to Docker, but we're gonna use Kubernetes today. As you can see here, there are 2 Kubernetes command and a YAML file that describes the deployment. So Kubernetes command first creates a credential, the same credential we created here, a token, and then it applies the YAML below. So quite simple. So I'm going to download the file, right? And then I'm going to copy this command from here. Oops. And go to my Visual Studio Code here. So I'm running a Minikube environment. And you can actually see it here. It's fairly empty. There's nothing except system pods running in, right now. So I'm going to take this command I just copied and paste it here, right? And at this point, we need to just do one thing. We need to drop the downloaded YAML file here in this directory. And at this point, we are ready to deploy. So let's go and do it. So first of all, let's look at this deployment, gateway deployment YAML. So you see, we are actually providing configuration endpoint here in a config map. We've got a deployment with 2 replicas for resiliency. It pulls an image from MCR and we take latest. There are 2 ports, one for HTTP and for HTTPS, very straightforward. We feed environment variables, which contain gateway token, which is a secret that we're going to create with a command. And then we provide a config map that provides the rest of the parameters. And then we expose those ports through a service of type load balancer, again, 2 ports mapped to 80.443, and the name of that service is gateway. So very, very straightforward. So at this point, I'm going to create a namespace for this, right? So let's run that command. So namespace is created, and we can actually see it here now, right? We've got API gateway namespace. So at this point, let's go and create secret. So run that command. Secret is created. Again, we can validate that now we have gateway token, right? And that's what our deployment YAML consumes. And at this time, we are ready to actually run the command to apply the deployment. And so this time we can see that we've got gateway deployment with 2 ports exposing a service of type name gateway, type load balancer with 2 ports, right? So everything as we requested in the YAML file is now we have the deployment created. We can actually take a look at the logs here and just make sure that everything initialized well. So as we can see, there are no errors. There's a bunch of output here in the console, as I mentioned. And you can see that by default, since we didn't configure persistent volume, we have this little warning that configuration backup is not enabled. That's okay, you can safely ignore it. This warning will disappear if you actually provide a persistent volume configuration. That's super easy to do, it's well documented, I'm not gonna worry about it. So at this point, everything seems to be working fine. So now we can actually go in and try to test this deployment. For that, I need to expose that service within the Kubernetes cluster on my local machine. And I do it with this port forwarding command. So now port forwarding started. And I'm going to open a different window here. So at this point, I have this little test HTTP REST client file. So I'm going to configure, as you can see, I'm going to configure to use local API, right? And we, as you remember, we are forwarding to these ports. So I'm calling on port 8081, which is an HTTPS port. And so here we can do a get. Let's see. Resource not found. Interesting, right? Kind of expected though, right? If you remember, we kind of didn't do anything with this API configuration for the gateway. So essentially, even though the API is defined and you can actually call that API through the cloud instance, right? It's not available locally because we didn't configure it to be served from this local gateway that we created. So for that, it's very easy to actually change. We can come here. Let's see here. You see, this is the gateway we created. So all I need to do is I need to come here and add this API to this gateway, and basically which tells this API that it's okay to start serving this API. And now we should be able to make a successful call. It takes a few seconds to propagate, and here we are, right? So everything is working. So now we're calling our local API here. The request still goes to the cloud web app, right? So you can see that we're still calling web app, but it works, and we're calling it through the local gateway here. All these operations work. Delay will wait for 2 seconds and then respond. So everything is great. Lovely. So let's go back and talk about caching. So For caching, to test caching, I'm going to use Artillery, which is a free tool. It's basically a load generator for HTTP endpoints. So I have a configuration file, and essentially sends 5 requests over 5 seconds, so 1 request per second. And right now, it essentially targets Cloud API at 1 Azure API.NET, HTTP bin delay 1 second, right? So if we run this command now, right, we're gonna see what kind of performance we're gonna get. So it just takes a few seconds. All right, so the median response time, right, is about 1 second, 1 second, 1.1 second, right? Which is expected, right? Because basically we're asking to delay for one second, and then there's round trip on top of that. So all makes sense. Definitely no caching, right? So that's good. So let's go and configure cache policy. So again, I'm going to use extension here. I'm going to go to HTTP bin API, and I'm going to go and apply a policy. So I'm going to do cache. Oops. What is going on? Here we go. So we're going to do cache lookup. We're going to take all the defaults. So I'm going to just close it here, remove the rest of it. And we're going to do cache store, obviously, on this side. Cache store. And we're going to do 60 seconds. Doesn't really matter. So hopefully that will work. I think it did. So now we apply the policy, right? Caching policy to our API. So let's run Artillery command again and see what performance we're going to get if the cache actually is working. All right, it does, right? So now, obviously, after the first request came in, the rest were served from cache. So you see that median went from 1.1 second to 143 millisecond. We can try it again. Probably will be similar result, maybe a little faster because we have 60 seconds caching. Yeah, a little faster, median 79 milliseconds. Cool. So the caching is working, but remember, we've been calling actually Cloud API with that, right? So let's call through local gateway and see what happens here. All right, so median is over 1 second, right? What's going on? Well, what's going on is that Self-Hosted Gateway does not actually have built-in cache. So the caching policy, even though it's configured, Self-Hosted Gateway has to ignore it because there is no cache for it to use. So, but we can easily fix this by going and deploying Redis cache within the same cluster, right? And enable cache. So here I have essentially a YAML file, super simple again, that deploys a single pod of Redis, exposing it on port 6379, and the name of the service is Redis, right? So I'm going to run the command, and I'm going to deploy it in the same namespace as the API gateway. So let's do that. So at this point, we should be able to actually go and see that we have 2 deployments, one for gateway, the other for Redis, and we have a single pod of Redis running here. We've got a service, and the port is 6379. The name of the service is Redis. So at this point, we've got essentially external cache running in the same environment where the gateway is. So all we need to do is go back here and configure external cache, which is super easy to do. So I'm going to basically say, okay, Redis 6379, right? That's the that's the name of the service, port 6379. Kubernetes DNS will resolve Redis to the correct IP address within the cluster. So let's save this. So now we have actually configured our external cache. So hopefully, if we did everything correctly, we can rerun the artillery command. And again, we're running against local gateway. And what we should see is that now the cache is working for it. So fingers crossed. Yeah, 42.5 milliseconds locally, obviously faster than going to the cloud. So as you can see, cache now is enabled in the self-hosted gateway through basically deploying Redis cache within the same cluster. Awesome. So last thing we're going to do here is we're going to configure backend in the same environment and basically direct the cloud instance to use HTTP bin container running on web app, and locally it will use the container we deploy on-prem. So for that, I'm going to create a separate namespace for the backend called backend service. Okay, it's done. And I'm going to go and deploy HTTP bin container into that namespace. So let's run this. So at this point, we can actually have backend service. We have HTTP bin deployment. We're running 2 pods exposed through a service, which is called HTTP bin, and it has a single port 80 exposed, right? Cool. So at this point, we can actually configure logic within the policy that will tell us to, will tell the API management to use different backends depending on where what gateway is serving that request. So let's use choose policy for that. Here we go. So let me just grab my cheat sheet so I don't make a typo. Here we go. So the condition will be, we'll key off the location of the request, right? So here we're gonna paste that, right? So, and if location is Seattle, which was the location of our backend, I'm sorry, of our gateway that we created, we are going to call HTTP bin backend service, right? Local HTTP bin. Otherwise, we're gonna just go and use the backend in the cloud as we used to, right? Here we go. So let's upload. Hopefully we didn't make any mistakes here. Still updating. Updated, so everything is good. And at this point, we can actually go and test that. So if we call local, right, we should see response coming from the from HTTP backend service, right? So our policy is working. So when we're calling locally, local gateway directly, we are receiving response from the backend that is running locally. But if we change it to the cloud, what we should see is response from the web app that we deployed. So let's go and look at that. And of course, yes, it's coming right from there. So now essentially we have gateway in the cloud, gateway on-prem, both talking to exactly the same backend API, one deployed in the cloud as a web app, the other one on-prem. So hopefully that's clear. So cool. So we have about 10 minutes left. So I'm going to be, I guess, adventurous and see if we can push it a little further with the demo. And for that, I'm going to switch to demo number 2, which essentially will demonstrate how to deploy local telemetry collection. So here, essentially, I have a couple of things. I have, actually, to go forward with this, let me just copy. Let me just copy this file into this directory right here. Perfect. So essentially, the way it's going to work is this. Oops, this is in the way. All right. So the way it's going to work is we're going to deploy a pod that will contain statsd and Prometheus, right? We'll configure our gateway that runs on-prem to talk to basically output information to statsd. And that will be consumed, scraped by Prometheus every 3 seconds. And then we're gonna essentially talk to Prometheus through a dashboard, Prometheus dashboard in the browser to view the metrics. So that's kind of the idea here. So without further ado, let's just go and create namespace for telemetry. Let's go and deploy Prometheus and statsd. So everything is fine. So should be running here. Oops. You can basically see all of that here. We've got some services here, Prometheus and statsd, everything is fine. So one last thing we need to do is we need to actually tell our gateway to go and output telemetry into statsd, which is very simple to do with these settings. So we're gonna just go and change our YAML file that we use to deploy the gateway to add a few configuration parameters, basically saying output statsd metrics to this particular IP within the cluster, and do sampling rate of 1 second, then use specific format there. So with that done, so what we need to do here is we need to go and update our deployment. Let's see, this is the wrong CMD. Here we go. So we're going to update the deployment. So to apply these new settings, done, right? And we need to also do rollout restart of the container pods, which contains Self-Hosted Gateway, to pick up these metrics. So let's restart the port forwarding. And then we need to also port forward from the Prometheus, right? So we can actually talk to it. And at this point, we are actually ready and we can launch dashboard here that should be talking to Prometheus running within our cluster. So at this point, everything is right. And last thing we do, we're going to generate some load. So we're going to run again, use artillery to generate some load, and hopefully, oops, wrong thing here. Let's just do this. So now I'm generating some load. It will take a few seconds for Prometheus to actually scrape the metrics. So we're gonna keep running and looking for requests. So you should see a metric coming which is called requests here. Yeah, here it is, right? And if we execute it, we can see that there is there's a load coming. Oops. There's load coming towards your cluster. This is artillery working. So as you can see, very easily, I hooked up local metric collection and display to our deployment. So with that, let's go and finish the presentation. So what's next for the Self-Hosted Gateway? First of all, I mentioned that right now we are putting only metrics into Azure Monitor Log Analytics, but not logs. So that's coming. You saw that we're using SAS tokens that we generate from a couple of keys to authenticate gateway to API management in the cloud. So we're going to be introducing a set of alternative credentials based on Azure ID, so that you can use either one, depending upon what your requirements are. Right now, we actually don't support custom CA root certificates that are configured within API management. They don't propagate to the gateway. So that's something that we're going to add relatively soon. Upstream TLS and Cypher configuration coming as well. And then the most important thing that will drastically simplify all these deployments. You saw that to deploy right now Self-hosted gateway, I had to actually switch to Kubernetes control plane, use kubectl. Then of course, when I need to upgrade my cluster, I will have to use kubectl to do rolling upgrades if I want to upgrade to a new image. So what Arc for Kubernetes will allow us to do, and as you probably know, Azure Arc is sort of the hybrid and multi-cloud strategy for the whole Microsoft, and it's a layered strategy where essentially we'll introduce support for hybrid and multi-cloud at all the layers of the stack, starting from VMs up. Specifically for Kubernetes, it will allow you to essentially inventory and view all the clusters, Arc-enabled clusters anywhere inside the Azure portal, and then automatically manage and deploy into those clusters. And so we're going to leverage that capability so that you can essentially deploy and keep self-hosted gateways up to date on these Arc-enabled Kubernetes clusters that could be located on-prem or in other clouds, so that you don't really have to worry about using kubectl or switching sort of management planes. Everything would be you will be able to do everything with the management plane in Azure. You don't have to context switch, and more importantly, you can keep your API management gateway running in Kubernetes also updated, similarly to how we sort of transparently and seamlessly update our cloud managed gateways. We'll do the same for your gateways as well, which you remember that when we contrasted distributed and unitary API management, distributed had a little bit more sort of operational overhead that is placed on customers. So with Arc for Kubernetes, we can minimize that very significantly. So keep an eye out for it. We are very excited about that capability. I think it will be really useful to customers who have distributed deployments. There are a few limitations. We already saw that built-in cache is not available, but it's very easy to use external cache for that. That was sort of by design. And there's a few other things that we didn't do, sort of by design at the moment. So obviously, looking for feedback on that, but I wanted to make you aware of these. You'll find all information that you need and about API management and self-hosted gateway on this APIM love short URL. So please take note of that. And with that, I think we are done. Mohan, I'm not sure how to view questions. Can you help me with that, if there are any?
Yeah, sure. We have a couple of questions from the attendees of that. So I'll read it out one by one, if that's okay.
Mm-hmm.
Yeah. So the first question is from Rexon. So we can state it currently, the self-hosted gateway is available only with a premium plan. So any plans to expand to standard pricing plan?
So today it's available in developer tier and premium tier. Developer tier can be used in production, and it does have really limitations on the number of gateway deployments, but it has limitation on the number of pods per deployment. So as usual, with everything in API management, we are looking for market and customer feedback on our sort of approach to pricing, and I appreciate that feedback, and we'll definitely take it into consideration.
Okay, so we have a question from Bhaskar. So it's on, could we combine self-hosted gateway and a standard plan to reduce cost and improve compliance?
It does seem to me that this is a similar question, right, to the previous one, because again, it talks about self-hosted gateway with a standard plan, and currently a self-hosted gateway is only part of the premium plan.
Okay. So the question from Siddharth is that, can we create a proxy around the HTTP endpoint and expose it via gateway? And also, does the HTTP endpoint has to follow any API specifications?
No, I'm not sure I understand the question, but essentially self-hosted gateway can, as a managed gateway, can be used with any HTTP endpoint, right? So, I hope that that's helpful. If not, please just follow up with me offline, and we can sort of dig into the question.
So the question from Marcelo is that how to deal with cache invalidation in APIM plus Redis?
Cache invalidation it happens automatically. So we have, you assign TTL and we kind of evict cache based on that. There is a policy that we provide that allow you to invalidate cache entries as well. So that's basically exactly the same for external cache. So there's really no difference. Currently, the format in which we store information in cache, as well as the format of the cache keys, is internal and not published. So therefore, you can't really leverage any Redis capabilities for managing the cache.
Okay, so the final question from Rohit. So what changes are required in firewall for on-prem self-hosted gateway?
So for self-hosted gateway, the only thing it needs is connection to Azure on port 443 outgoing. So that's basically the requirement. So right now we are not really locking it down to a specific IP address or IP address range, but that's something that we're working on. And for customers who need it, we will offer capability to essentially have just a single IP open on port 443 outbound from their local environment. And we'll funnel everything through that single port and single IP.
Okay, so these are the questions we received from the attendees, so Vladimir. So would you like to add a closing note?
Yeah, thank you very much. I appreciate you guys attending the presentation. Hopefully it was useful. It was a bit quick, but there was a lot of material to cover. So I hope you'll see that the Self-Hosted Gateway now gives you significant flexibility in how you manage your topology and how you manage your traffic. It is very easy to deploy. It's roughly functional equivalent and will be made, even more so with the managed gateway. So you can actually define policies without really thinking, which gateway this policy will be executing on. It has some limitations. For instance, it doesn't have built-in cache, but it's very simple to augment that with a Redis cache, and there's, simple sort of moves that you can take to deploy it. It has, full observability in the cloud and on-prem. And keep feedback coming as usual. Hope you'll start taking advantage of this capability and let us know how it works for you and what we can do to improve it.
Thank you for your wonderful session, Vladimir. So we'll be catching you all in the next session. Yeah.
Thank you.
Cove.co